All right, so 2022 AP Calculus BC exam question number 5 coming up. I am Mr. Carboni. I've been teaching AP Calculus for like 17 years. I'm working these problems and I'm reading them for the very first time. So you get to watch me process and read the problems and try to analyze what's going on here. May have to pause the video to think some because sometimes these BC questions trip me up. So number 5, non-calculator question. We have two figures. We have a region R, a region W, the graphs of 1 over x squared, blah, blah, blah. A lot of these words in this big old paragraph are simply describing what I'm looking at. So W is unbounded. There's probably an improper integral coming our way. Find the area of region R. Wow, that is a nice question. A, area of region R would be the antiderivative from 1 to 5 of the function 1 over x. Holy cow, this is nice. Find the antiderivative, write it down. That would be the natural log of x. I guess I'll put that in absolute values, even though from 1 to 5, the absolute values will not come into play. Evaluate that from x equals 1 to x equals 5 would be the natural log of 5 minus the natural log of 1, and the natural log of 1 is 0. So you can just write that as the natural log of 5 for your answer for A. And wow, that was nice. That's a BC question? What? All right, number B, the region of R is the base of a solid. For each solid, at each x, the cross section is a rectangle with area given by that. Find the volume of the solid. Okay, they're kind of nice on this one. This is going to be an integration by parts. Anytime we find volume in AB, unless you're doing shells, which is not in the, I say AB, in AP calculus, unless you're doing shells, which is not part of the curriculum anymore, you're always going to do the antiderivative of the area of your cross section. And they were kind of nice here because they just straight up told you the area of this rectangle is x times e to the x over 5, which I'm going to rewrite as 1/5 x just for personal preference. And we're going to find the antiderivative of that area. We're looking at region R, which would be 1 to 5, okay? This is a parts problem, and we can use the tabular method on this one. So I like to set up my parts problems this way. Some teachers like to set them up different ways. There's a reason I started at V double prime, and that is because as I choose my U, it will take the second derivative of U to take it down to 0. Therefore, I like to start with the second derivative of V up here, and it would be e to the 1/5 x. Technically, the dx is part of it. I usually don't write that. The first antiderivative would be e to the 1/5 x divided by 1/5, or 5e to the 1/5 x. The next antiderivative would be 25e to the 1/5 x. And so when you do the antiderivative here, you're going to do that product minus that product. So 5x e to the 1/5 x minus 25 e to the 1/5 x, and we will evaluate this guy from x equals 1 to x equals 5. And so plug in 5, that's going to be 5 times 5. I think that's 25. I feel pretty safe in doing that. E to the 1/5 of 5 would just be 1 minus 25 e to the 1/5 of 5, which is 1. Ooh, that's 0. Minus, plug in 1. 5 times 1 is 5. E to the 1/5 of 1, I believe that's 1/5, minus 25 e to the 1/5. And I honestly would leave the answer like that myself. However, this is really cute. This cleans up really nicely. That's 0. That's going to be a negative 20 e to the 1/5 x. And when we subtract that negative 20, the answer is 20 e to the 1/5 x. And I'm taking a risk by cleaning that up because you don't have to do that. But I feel like showing off. 1/5 x. All right, let's move on to B. Find the volume generated when W is revolved around the x-axis. And so this is going to be an improper integral, volume by disks. And so we're going to do the antiderivative of pi r squared. This will be with respect to x. This region begins at 3 and goes on to infinity. And my radius of this cross-section would be 1 over x squared. And so when I throw all of that into the antiderivative, it's going to be pi antiderivative 3 to infinity of 1 over x squared squared. And I think I'm going to write it like this first because I'm almost certain you will get points for setting up the integral correctly. Now, to solve an improper integral, you need to first write it as a limit. Limit as a goes to infinity. 3 to infinity of, and let's see, for this antiderivative, that would be x to the negative 4th dx. So 1 over x squared squared is 1 over x to the 4th. Bring that x up. And the antiderivative of x to the negative 4 is going, that's crap writing. It's x to negative 3 over negative 3, which is negative 1 over 3x cubed. So I'm going to come down here. Whoa, come back. I'm not evaluating the limit yet, so I'm going to continue to write limit as a goes to infinity. And the antiderivative was negative 1 over, holy cow, quit doing that. Negative 1 over 3x cubed. Evaluated from x equals 3 to x equals a. And don't forget there's a pi out here that's just coming along for the ride. Limit as a goes to infinity of, I'm going to plug in a first, negative 1 over 3a cubed minus negative 1 over 3 times 3 cubed is 81. Again, that's risky, but I feel pretty good about that. I know that negative 1 over 3a cubed will approach 0, which means the answer to this is going to be pi times 1 over 81, 0 plus 1 over 81. Now, if you really want to show off, you could write that as pi over 81. But there is my answer for part C. That is everything for number 5. So these are some fairly quick BC questions. Now, A was not a BC topic, but B is parts, that is BC specific, and integration of an improper integral is BC specific. So there is all of number 5. I don't see anything else. Nope, that's it. Let's move on to 6.